Hi students, in this video we will be solving question number 3 from the exercise 10.3 of the chapter straight lines, and this is a first PU syllabus. You go to playlists and look for straight lines. In that folder you will be able to find all the sums and derivations related to this chapter. Now let's check question number 3. Reduce the following equations into normal form. They have given us 3 equations in the form of ax plus by plus c equal to 0. We have to reduce that equation to normal form first. Then we have to write the perpendicular distance of that line from the origin. And also we have to find the angle between the perpendicular and the positive direction of x-axis. Okay. So this is the given equation. What is the equation of the line in normal form? That is x cos theta plus y sin theta is equal to p, where theta is the angle of inclination or angle between the perpendicular line and the positive direction of x-axis. If this is the line and the equation of the line is x cos theta plus y sin theta is equal to p, then this distance of the line from the origin, or this perpendicular distance of the line from the origin, is p, and the angle between this perpendicular and positive direction of x-axis is theta. The angle is not of this line, but it is of the perpendicular line with x-axis. Okay, keep that in mind. I have already made a video on derivation of equation in the normal form. It's a very important derivation from the point of view of first PU examination. In Karnataka PU board exam, in part D, a 5-marker question will be there from straight lines chapter. Keeping that in mind, this is a very important form. I will leave the link to that derivation of equation in the normal form in the description box, and also I will give it in the pinned comment. You can go and check it. I suggest you to watch that video first and then try to solve this so that you have better understanding of this. Now, x minus root 3y plus 8 equal to 0 is the given equation. The very first thing we have to do is to bring this constant to RHS. Now look at the standard form. It is x cos theta plus y sin theta. That is x and y terms in LHS and the constant term in RHS. So we are moving this constant to RHS. That gives us x minus root 3y is equal to minus 8. Now we have just understood that this p is perpendicular distance. Distance has to be positive, right? So we are going to make this term positive. So whenever you are asked to reduce any equation to normal form, first thing you are going to do is to bring the constant to RHS. If it is a positive quantity in the RHS, fine. Otherwise, you have to make it positive by multiplying throughout the equation by minus 1. So I am doing it now. So the equation becomes minus x plus root 3y is equal to 8. Now we have made this quantity positive. Now we have to express the coefficient of x as cos theta and coefficient of y as sin theta. That is what is reducing the equation to standard form. Now we have to do that. How do we do that? Minus 1 you can express for cos theta, but root 3 for sin theta, how do we do that? It is not possible. It doesn't take that value. There is something that we have to do. If you compare it to standard form of ax plus by plus c equal to 0, the coefficient of y is b. So we have to divide the whole equation by square root of a square plus b square. That is square root of coefficient of x square plus coefficient of y whole square. We have to do that now, which will be here minus 1 whole square is 1. And this is root 3 whole square is 3 under the root, which will be square root of 1 plus 3 is equal to root 4, which is 2. So that means we are dividing the whole equation by 2. That gives us minus x by 2 plus root 3y by 2 is equal to 8 by 2, which will be minus half into x plus root 3 by 2 into y is equal to 4. Now this minus half and root 3 by 2 has to be expressed in terms of trigonometric functions. Now when we do that, we have to ensure that the theta remains the same for both the functions. The value of theta cannot be different for sine and cos function. It has to be same because it is this single angle is what this theta stand for, right? So we have to express this minus half and root 3 by 2 in such a way that it satisfies both the trigonometric functions. So let us compare and equate the coefficients now. So I'm comparing the coefficient of x with this, which gives us cos theta is equal to minus half. And comparing the coefficient of y gives us sin theta is equal to root 3 by 2. Understood? Yes. Now we have equated. See, now we have equated it. And we already know that in first quadrant, all trigonometric functions are positive. In second quadrant, sin theta and its reciprocal are positive. And in third quadrant, tan and its reciprocal are positive. In fourth quadrant, cos and its reciprocal are positive. This we have already understood. Now, look at this. Cos theta is negative here. It is giving a negative value. Now you can see that cos theta is negative and sin theta is positive. Now it is clear that the angle is not in first quadrant. If it were to be in first quadrant, both sin and cos function would be positive. So sin theta is positive in first and second quadrants, but cos is negative. So angle definitely is not in first quadrant. So angle is in second quadrant because sin theta is positive here. Now in third and fourth quadrant, sin theta is negative. So the angle has to be in second quadrant and cos theta is negative in second quadrant. So angle lies in second quadrant. Sin theta is positive, cos theta is negative in second quadrant. So angle has to lie in the second quadrant. First we shall find the acute angle. Then we shall express that acute angle using the quadrant angle so that the angle lies in second quadrant. Okay. Now if you check, cos theta is half for what angle? 60? Yes. So I am retaining this negative sign. Minus cos theta is equal to minus half, or minus cos 60 is equal to minus half. And now sin 60 is equal to root 3 by 2. There is no confusion when it is sine function because it is a positive quantity. Now we have to express the angle in second quadrant, or we have to find an angle in second quadrant which satisfies these. Okay. Now to express any angle in second quadrant, we can write the angle as 90 plus an acute angle or 180 minus an acute angle. Do you agree? Yes. So if we express the angle as 90 plus an acute angle, 90 plus theta, then trigonometric function changes to its cofunction. So here we do not want any change in trigonometric functions. So we will express the angle in terms of 180 minus theta. Okay. If you express angle in terms of 180 and 360, trigonometric function does not change. But if you express in terms of 90 or 270, the trigonometric function changes to its cofunction. This fact you are already aware, right? So we are expressing this angle in terms of 180. Now, if you try to recollect, cos of 180 minus theta is minus cos theta, correct? Yes. Similarly, sin of 180 minus theta is sin theta because it's in the second quadrant and it's positive. Now, theta we have found it to be 60, that acute angle. Yes. So, we are writing here cos of 180 minus 60 is equal to minus cos 60. Similarly, for sin of 180 minus 60 is equal to sin 60. Now, this angle is nothing but cos 120. Cos 120 is same as minus cos 60. Do you agree? The value remains the same. Negative sign is introduced because of the quadrant. Is this clear now? Now, in the second quadrant, sin is positive. So, sin 120 is same as sin 60. There is no change in the sign because in these two quadrants, sin function is positive. Okay. Now we have got an angle. Look at this. It is cos 120. Here it is sin 120. It is satisfying both the conditions here. For the same angle, we are able to express the coefficients of x and y in terms of cos and sin functions. Clear? Yes. So it is cos 120 is equal to minus half and sin 120 is equal to root 3 by 2. Now we will replace this minus half here by cos 120 and we'll replace this root 3 by 2 by sin 120 so that we can express it in the normal form, which is x cos 120 plus y sin 120 is equal to 4. So this is the normal form of equation of the line. We were given in the form of ax plus by plus c equal to 0, which is the general form. Now we have expressed it in the normal form. So if both these coefficients of x and y are positive, then the angle lies in the first quadrant, and you don't have to do much about finding the angle. If there is a negative sign in one of those or in both the coefficients, then you have to look for the correct angle in a different quadrant. Now we can compare it with the standard form. When you do that, you know that the perpendicular distance is 4 and the angle of this perpendicular line with positive direction of x-axis is 120. So that's all. Till here everything is very easy. But if the signs are different, only then you have to look for an angle in the appropriate quadrant. For that you should know your trigonometric functions chapter very well. So it is very important for you to learn your trigonometric functions chapter thoroughly. Okay, now we shall go to next equation, which is y minus 2 is equal to 0. Now let us write the standard form. Now to express the given equation in the standard form, first we have to move this constant term to RHS, right? Which will be y is equal to 2. But we do not have an x term here. So we can write the x term as 0 into x plus 1 into y equal to 2. Now there is no negative sign here. It is easy for us to find the angle. In this sum, you will be directly able to find the angle or find theta, which satisfies both x and y coefficients. But if you just try to check what you are going to divide throughout by, that is root of a square plus b square, what happens? You just check, it is root of 0 square plus 1 square, which is dividing the equation throughout by 1. So the equation remains the same. Now we'll see, this is the equation and this is positive also. Now comparing the coefficient gives us cos theta is 0. So the angle is 90. Let us check, are we getting the same angle for sin theta also? This sin theta is 1. Yes, sin 90 is 1. Yes, we got an angle. Because the coefficients were positive, we directly got an angle which satisfied both. So we directly got an angle. We don't have to look for different quadrants now. So theta is 90 in this case. So let us substitute. The equation becomes x cos 90 plus y sin 90 equal to 2. So on comparing it with the standard form, theta is 90 degrees and perpendicular distance is 2 units. So this is the answer. Now let us check the next equation, that is x minus y is equal to 4. So this, if you try to write the equation in the form of ax plus by plus c equal to 0, this is the form. We'll write the standard form now. Then we'll consider the equation x minus y equal to 4. Now the constant is already in the RHS. Look at this, they have already given it in the RHS and it is a positive quantity already. So we don't have to do anything. What is the very next step? First step is to move the constant to RHS and make this perpendicular distance positive. If negative, then divide the whole equation by root of a square plus b square. That would be square root of 1 square plus minus 1 whole square, which gives us root 2. So we are dividing this whole equation by root 2, which gives us 1 by root 2 into x minus 1 by root 2 into y is equal to 4 by root 2. If we rationalize this, just check what happens. This is multiply and divide by root 2. So root 2 in the numerator and this becomes 2. So it will be 2 root 2 if you rationalize this term. Okay. Now just rewriting the coefficients. 1 by root 2 into x plus minus 1 by root 2 into y is equal to 2 root 2. So there is a negative sign in the coefficient of y. This is a positive quantity, but there is a negative sign here. So our angle is in not first quadrant. It is in some other quadrant which we have to identify. Now just compare the coefficients and equate the values. So cos theta will be 1 by root 2, sin theta will be minus 1 by root 2. So if you just check, the angle is 45 here. cos 45 is 1 by root 2. Sin 45 is 1 by root 2, but with the negative sign. You have to look for a quadrant where cos theta is positive and sin theta is negative. First, let us check which are the two quadrants where cos theta is positive. Cos theta is positive in first quadrant and in fourth quadrant. Correct? ASTC. So, either the angle has to be in first or in fourth quadrant. Simple. Since sin theta is negative, angle is not in first quadrant, angle is in fourth quadrant. You just check, sin theta is negative in fourth quadrant, cos is positive, sin is negative in fourth quadrant. Sin theta is positive only in first two quadrants, first and second. So, angle lies in fourth quadrant. It's very easy to find out. If sin theta is positive, angle has to be in any of these two. If cos theta is positive, angle has to be in any of these two. If both are negative, angle lies here. Very simple. Both are positive, angle lies in first quadrant. Easy to identify. Angle lies in fourth quadrant. Now let us find the acute angle. That is cos 45 is equal to 1 by root 2 and minus sin 45 is equal to minus 1 by root 2. Now we have understood that angle lies in fourth quadrant. Any angle in fourth quadrant can be expressed as 270 plus an acute angle, that is theta, or 360 minus theta. So if we express angle as 270 plus theta, then trigonometric function changes to its cofunction, which we do not want in this case. So 360 minus theta is the better choice. When we express an angle in terms of 360 or 180, the trigonometric function does not change. So in this case, we are expressing the angle in terms of 360, which will be 360 minus theta, which will be little less than 360. So angle will lie in fourth quadrant. So it is cos of 360 minus theta equal to cos theta. Similarly, sin of 360 minus theta is minus sin theta, fourth quadrant. So we will write for theta as cos of 360 minus 45 gives us cos 315 and sin of 360 minus 45 gives us sin 315. So we have got the angle now in the fourth quadrant, which is 315. So we will write it. Cos 315 is 1 by root 2 and sin 315 is minus 1 by root 2. Why are we writing for both the terms when cos 45 was already positive and it was fine and it was right only? We have to find an angle which satisfies both x and y coefficients. We have to get a same angle. We cannot have two different angles for sine function and cos function. Is this clear? Whatever changes or whatever way you try to express the angle, we have to try to express the angle for both sine and cos functions. So this is the angle 315. Now we will substitute for 1 by root 2 and minus 1 by root 2 in the equation, which gives us x cos 315 plus y sin 315 is equal to 2 root 2. So compare it with the standard form. That gives us theta as 315 and perpendicular distance as 2 root 2. That's all for this sum. It's an easy sum only when you understand and learn your trigonometric functions. Otherwise, you will be able to write only till here. And if you know your trigonometric functions, only then you will be able to proceed from this step to this. Otherwise, it becomes very difficult for you. So, learn your trigonometric functions chapter well, thoroughly, because you will be using it in the whole of first and second PU. So if you still have any doubt, please do mention it in the comment section.